Good morning. We are dealing with the building material, very traditional, natural building material, timber. Now, timber has only a limited use in construction because the timber wealth is depleting, and to safeguard the flora and fauna and to reduce the ill effects or environmental impact due to global warming and climate change, timber cutting is discouraged. There are rules, legislations by which the forestry has to be maintained and upgraded by planting more trees. The slogan of the day is plant more trees, one person at least one plant, not cutting or felling the tree. Cutting the process of tree is known as felling the tree. Felling the tree is discouraged and planting more trees are encouraged. Anyway, timber, natural timber, even though natural timber is use of natural timber is reduced in the construction industry, you have artificial timber, synthetic timbers, man-made timbers. Manufactured timber is very much used as functional materials, more as functional materials for the shutters of doors, windows, tabletops, for furnishing. One such timber is plywood. Plywood. You have plies, and they will be glued together by which you get different thickness of plywood. Another thing is block board. Block board. Then you have synthetic wood such as Novopan. Novopan, in which then mica sheets will be put over the artificial timber panels. We'll be putting the mica sheets are readily available. A smooth textured veneer will be glued to the base of an artificial timber. It is Novopan. Then you have rubber wood, soft wood. Woods are, you are having hardwood and softwood. The timber structural use of a wood, at that time that wood is called timber. For furnishing and for most of the furnishing, timber is a versatile furniture material. For the use of furniture, you have nowadays mechanical devices, electrically operated mechanical devices such as planer, lathe, driller, for carving and shaping the timber in different forms, for handrails, for monuments, for decorative works, for furnitures. Variety of furniture with different ergonomical facilities are coming, and this can be done with the mechanization of the timber making. So in furniture field, timber plays a very important role, even though it has started reducing its usability in actual construction to take structures. Even wooden doors and doors, windows and ventilators, that's a set. In earlier period, they were the only monopoly, it was the monopoly of timber to have doors, windows and ventilators because they are highly resilient, they are shock absorbing, they are a non-conductor, they are insulating in nature, and you can render different paints and color. You can have timber such as teak wood. Teak wood is a structural timber. Rosewood is a structural timber. Then you have neem, vape, neem. Then you have irul. Then you have the bark or the planks of the jackfruit tree is very workable for furniture and the shutters of doors and windows. For the frames, people may go for teak wood or teak wood usually. Rosewood is very costly. Rosewood for decorative purposes and for furniture. So there are varieties of structural timber and non-structural timber. Non-structural timber is called as wood. If you say timber, usually it is structural timber. Timber is very capable of taking compressive strength as well as tensile strength. The compression value will be different if the timber is cut along the grain. During the process of cutting, you have to see. When the timber is cut, you have the cutting machine, you have the sawing machine. When you saw the timber in such a way that the grains are parallel to the load, applied load, you have to cut in such a way that you will get one compression parallel to the grains. If you just keep it like this and if you apply it is not perpendicular grain, you have to cut the piece from the timber itself in such a way that the grains are perpendicular to the load. So compression test on timber pieces, usually the timber piece will be around 20 centimeter length and 5 centimeter by 5 centimeter cross section. Compression test will be carried out, compression parallel to the grain and compression perpendicular to the grain. This is not just keeping the vertical member or horizontal, making it perpendicular to the grain. The piece has to be cut in such a way that you get grains which are perpendicular to the action of the load. Usually compression parallel to the grain and compression perpendicular to the grain, parallel to the grain will be more than perpendicular to the grain. The reason is that timber grows. When the any timber grows, the grains, the lines also grow. But the foundation is fixed. The bottom, the root of the tree fed to the soil as foundation of a building, and one point is fixed, the other point is growing. So initially they are subjected to tension. There is a pre-tensioning taking place. So there is a reserve tensile stress on all the grains. So when you apply a compression load, first whatever has been elongated because of the tension has to come down, then only the stress will be transferred to the piece. Till that, there is a reserve compressive stress due to the initial tensile stress while the tree, a living tree, was growing. That is advantage. So it is a principle of pre-stressing that is very well applied. It's a natural pre-stressing taking place in all the living trees. But that is induced in the construction of beams, bridges. Pre-stressing is a popular method of initially stressing the structural elements before they are subjected to actual loading. But in the case of growing of trees, a natural pre-stressing is taking place. So that is why compression parallel to the grain will be more than compression perpendicular to the grain. Then you can apply the tension and you can get the tensile strength also for the timber. Timber is comfortable to take compressive load as well as tensile load. If you just see the cross section of a timber, it's circular. Usually, if you just take a circle, the outer skin of the timber, is called bark, B-A-R-K. So the outside of the bark is outer bark, the inside of the bark is inner bark. It is the cover, it is the protection. Whenever this bark is disturbed, usually because of the woodpecker, because of the termite attack, because of beetles, because of marine insects, if that bark is opened out, then the timber starts decaying. So bark is the mark of strength of a timber. If the bark is well protected, well maintained, well in position, so with sufficient thickness, having outer bark and inner bark, that timber will be safe against natural forces, against insects, against seasoning, right? That is the first thing to be removed. First layer. Inside that, the next layer, these are all layers in plant, in a circular thing, is called just adjacent to the inner bark. That layer is called the cambium layer. Few portions. Cambium portion, cambium layer. The center core is called the pith. And pith imparts strength to the timber. Whenever this center pith is more and more, and it will be more and more whenever it is growing. Pith. So center portion is pith, bark, then you have cambium. Around the pith you will have so many annular rings. Annular rings. And radial lines. So just visualize. You have a timber cut across. You will see the outer and inner bark, then the cambium, then at the center the pith. Near the pith, spread of heartwood. That portion is called heartwood. And near the cambium, it is sapwood. Whenever the timber is growing and growing, heartwood will go on increasing and sapwood will go on getting reduced. If that is taking place, the timber is getting its strength. So heartwood should be more compared to the sapwood. Sap means moisture. Outer will be having moisture. Pith, then heartwood, then sapwood. So these annular rings covers the heartwood and sapwood. The radial lines are called medullary rays. Medullary rays. They radiate from the pith. Medullary rays. They connect the pith and the cambium. They connect the pith and the cambium up to the inner bark. So medullary rays, heartwood, inner heartwood, outer sapwood, innermost pith, just like a nucleus, and inner bark, outer bark. So these medullary rays will get water, and that water will go up due to capillarity. That water will go for capillarity. They supply water from the bushes. Then that stem grows, then you have branches, sub-branches, leaf. This is the cross section and the longitudinal section. The longitudinal section means it's a vertical. You can see outer bark, cambium, sapwood, heartwood, with medullary rays. Now, what are the defects of timber? Timber is susceptible to fire attack, very combustible. Once fire comes, gone, the whole structure will go to ashes. The most susceptible material for fire attack is timber. That's the most greatest defect or disadvantage of timber. Then timber will have sensitivity towards insects, natural insects. We will continue tomorrow. Thank you.